This is Ms. V, and we're here to talk about weld joint design, welding symbols, known as blueprint reading. So, here we go. So, we're going to be talking about a couple of different things. Hold on, if my computer will go forward. Here we go. So, we're going to talk about basic types of joints, types of groove welds, symbols, what joint preparation or edge preparation is, and non-destructive symbols. Okay. Some of the key terms we're going to look at are groove, fillet, weld joint, weld location, and welding symbols. So there are many factors that affect the type of weld joint to be used and how we select it, okay? So we'll talk about different factors. Welding symbols are an abbreviated shorthand that is used on welding blueprints. So once you understand the code, you'll be able to decipher what's written. Okay, so weld joint design. This refers to the way pieces of metal are put together or aligned with each other. So there are 5 most common joints: butt, lap, corner, T, and edge. And let me show you what they look like. So this is a butt joint. It butts up with each other. A lap joint. It overlaps it. T joint. It looks like an upside down T. Outside corner. Okay. And this would be an edge right here. Okay, so when we talk about a corner joints can be fit up in a different couple of ways. So we can have them that makes a little V groove, an outside corner here, but we can also butt them edge to edge and it forms a square butt joint. And if you guys need some more information on this, you guys can also go to the video library. It says what you need to know, and we talk about joint design and positions. Okay, so edge joint. This is an example of different types of edges. When we're talking about edge, we are meaning to weld on the edge regardless of the shape of the material. So we can see that this material has a little groove on it, or I should say a bend in it, but we're still only going to be welding on the edge. Okay, so let's talk about joint design and controlling distortion. When we weld, we can also make distortion when we heat up the metal. Using a jig or a clamp can help us not have warping or as much warping. So in the example, the vertical members are welded first on one side. So this is the vertical members. And it's welded first on these sides first, all on the same side. And then you put a weld on the other side. So in theory, it makes it a little easier to keep it parallel and from going off center. But when we weld a joint that has multiple passes on both sides, we would probably put one pass and then another pass, one pass and another pass, until it gets to the amount of passes that are necessary. Okay, so let's talk about joint stresses. There's a lot of stresses that come when we're putting 2 pieces of material together, okay? And they can affect your welds and whether or not they actually stay together. So the most common stresses are tensile, or how strong the material is by pulling it apart, compression, or how strong the material is by pushing it together, bending force, this is something that goes back and forth, side to side, a twisting force, well, that's kind of twisting, or torsion, and a shear force is almost like peeling apart a piece of material. All of these forces are at play. So your weld needs to be able to withstand these stresses or forces. So there are different factors that can cause these forces. Having a poor contour or shape of your bead can make unnecessary stresses. So here are some of the rules that you might think about when you're looking at these things. We want to make sure that we match the base metal with the filler metal. Rule number 2 also tells me to make the filler metal as strong or stronger than the base metal. This helps me immensely to make sure that my joint is going to withstand these forces. And then the last rule is 90% of the time, the thickness of the material also dictates my settings and or joint design. So let's keep on going. Welding process. Well, we know that there is not one process that will do it all. Okay, so how do you choose the right process for the job? Welding processes can affect the performance of the joint. Travel speed, penetration, deposition rate, and heat input will also affect the decision for your joint design and the proper welding process. Part of that, though, is edge preparation. Edge preparation is a term for how the material is being prepared for a weld. A faying surface, okay, is the surface that's going to be melted during the welding process. An edge preparation can be made on one side or both sides. So this would be an edge preparation on one side. This would be an edge preparation on both sides of the members. Okay, so edge preparation also allows the weld to have proper penetration, have the correct appearance, make the weld stronger, and in some cases, codes and standards require particular edge penetration to get complete joint penetration. So here's another reason for edge preparation. So let's get this example. There's a crack in an engine block. I don't know if you guys can tell, but this is supposed to be a crack in an engine block. So how do we repair it? Well, in order to repair a crack, regardless if it's an engine block or not, you need to drill the ends of the crack so it does not continue through the material or your weld. Okay? Then you need to grind a little groove right where the crack is. We want to grind the crack out. So once we grind out the crack, we can weld it. And after it's welded, then we can grind the weld flush. Okay? This is edge preparation. We're beveling or grooving that area so that we can put material in it and make sure that it is sound. Joint dimensions. Okay? In many cases, joint dimensions are used on the blueprint to have a correct size, shape, and angle. Groove angle, this is this angle right here, can also be called included angle. This is the total angle of both sides of the joint. The bevel angle is on one side of the joint and the degree or angle in which the member must be prepared. So this is bevel angle here. Okay, so if they're asking for a groove angle or an included angle of 45 degrees, my bevel angle is half of that, which would be 22.5. So that makes this 45 degrees. Now, root opening. This is root opening right here. Root opening is the opening between the two members of the joint. Okay, so this is important to know how big or small this is. This can also change my selection of material if this is too big or too small. Size of the root face, that's right here. Okay, this can also be called the landing. How much should be there to properly put a bead in the joint is ultimately what needs to happen, and usually it's around a 32nd to a 16th of an inch, just enough so that your root pass can get in there well. Depth of bevel. This can be a little confusing, guys. This is also referred to as size of weld or size of groove. This can show us whether or not the weld will go all the way through the material. In the example shown, the depth of bevel is the same thickness as the plate. If there was not a size noted, then the depth of bevel or groove is considered the size of the material. In other cases, though, the groove or depth of bevel is less than the size of plate. So what will happen, let's take this for example, this is a 1-inch plate, and they say depth of bevel is 1/2 or 1/2 inch, which means this angle will only be done 1/2 inch, and then this material here will still be there. I hope this makes sense. All right, let's keep going. Metal thickness. Thickness of material can change the type of joint that may be used. Edge preparation is used on thicker materials to ensure that the weld goes all the way through the joint. This is called complete joint penetration, CJP. So here are some of the different types of edge preparation you may see. Okay, so the first one, single V groove. Okay, we're talking about it only on one side. Okay, now double V. This means the V is on both sides. So if it's on both sides, we call it a double. All right, this one can get confusing. Single bevel, which means only one member is prepared. Now, double single bevel. Okay, that means both sides of this are being prepared. U groove and J grooves, they're not seen quite so much, but you need to understand, okay? So these types of joints usually do not go all the way to the other side, and they're usually considered PJP, or partial joint preparation. As we can see, if there's no root opening, how can I make it go all the way through or have complete penetration? So this would be a single U. And then in plans and documents, it will say how thick it is and how thick this is. Okay, same thing here. Double U, it's on both sides. J, okay, double J. So we can see that there's material here that does not make this complete. Okay, so onwards. We can do what's called back gouging. Back gouging is a method that allows for complete joint preparation, or I should say not preparation, penetration. It's CJP. So the American Welding Society says the back gouging is the removal of weld metal and base metal from the root side of a welded joint to facilitate complete fusion and complete joint preparation or penetration upon subsequent welding from that side. So what are they saying? Back gouging is done after the first weld is made on the other side. It can be ground or air carbon art to use on the other side of the metal. Another weld is put on it after it's ground so that there's full penetration. So, for example, we make a weld here and our groove is here. So we'll do this one first. We'll grind or gouge so that when we put this next weld in, it will be complete joint penetration. Okay. So different types of metals have different characteristics. Some have high thermal expansion, like aluminum, or others crack or distort once they're welded. So we also may need to take that in account for our joint, if the joint can be ductile at all. And then welding position. Welding position can affect the way a joint is designed and whether you can access it, okay? So when welds are made out of the flat or horizontal position, it is referred to being out of position. Most of the time, the most ideal position would be flat or horizontal, okay? Because we can get a little bit more penetration and we can control the bead a little bit better. Onwards. Okay, so here are some of the welding positions that we've gone over in the past. If you need more understanding, please see the video in the video library that's called What You Need to Know in the video library. Okay, so there are two major types of joints. A groove, this would be a groove, or a fillet. Groove is abbreviated by the letter G. Fillet is abbreviated by the letter F. Who would have thought? All right, so for every position, then there is a number that abbreviates this. So 1 is flat, 2 is horizontal, 3 is vertical, and 4 is overhead. So we can look at it like this, okay? So a joint that is 2F is what? 2F is horizontal and it is a fillet. And we can see how a change in the position changes the way our weldment is sitting. Okay, and usually when we weld, we're not able to move our weldment around like in a building. So we have to be able to understand how to weld in those positions. Okie dokie. So we must remember that joints are not referring to the position of the weldment, but rather the which way your electrode is pointing. AWS states that welding position is the relationship between the weld pool, the joint members, and the welding heat source during welding. I hope that helps. Okay, so we're going to talk about a little bit about pipe welding positions here. They can get a little tricky, so roll with me, okay? So we know that it says 1G, 2G. Well, we know that G is for groove. When we put these two pieces together, it makes a, you got it, groove. Okay, so 1G in pipe, it refers to the horizontal position of the pipe, and the pipe is rolled in order to make the welds. Yeah. Okay, so this is what it would look like. Okay, so we would be going up. 2G, it refers to the vertical position of the pipe, and the pipe is rotated to make the weld. Now, everybody says, well, what happens to 3G? Well, 3G got thrown out a long time ago, so we're not even going to worry about it. Okay, so 5G. This refers to the pipe being horizontal and the weld being vertical, but here's the but. The pipe is no longer rolled. Okay, that's it. It's in a fixed position. 6G. This refers to the pipe being stationary at a 45 degree. And this is a position that many pipe welders use to get certified because it covers all of the other positions. But it is stationary here. It's not moved. So you have to go all the way around. This means that you have to understand how to do flat, horizontal, vertical, and overhead welding. Now, I added another position in here for you guys to understand. It's called 6GR. The R is for restrictor ring. So the pipe is still in a 6G position, but there's this fancy little restrictor ring, okay? And it's attached to the pipe, making it much more difficult to weld. And the restrictor ring is about 18 inches, and they place it about a ½ inch above the weld. So it makes it a little bit harder to get in there, and sometimes you have to use a mirror and understand how to do it, okay? Okie dokie. So, certain codes or standards may require specific joint designs to ensure proper penetration and the weld will properly hold. One of the most common codes or standards that you may see is AWS D1.1 for structural steel. This is pretty much the Bible of welding and structural materials. And a lot of other codes and standards are based on the D1.1. And we want to make sure that, you know, there are many other codes that are specific to types of material and their uses. So if you're doing pipe, well, you can be doing ASME or you can be doing API. So it's very specific to then the industry. Okay, here we go. So sometimes the skill of the welder may also come into play when deciding what type of joint, okay? Other problems with joint design is that the joint was designed by an engineer and it works on paper, but there's no adequate room to be able to access the joint or even see what's going on. So sometimes it has to go back to the drawing board and the engineer goes, well, I can draw it. Theoretically, it should work. Well, that's the problem. Theoretically, it works, but you can't get in there. So sometimes joints have to be accessible. All right, here we go. Acceptability of cost. Well, we know that different joint designs come with different costs associated with them. Well, what affects the cost? Well, we have to remember that using certain processes, it can allow for a reduction of groove angle, which means in terms of cost and time, a smaller angle can allow for less passes and the joint can be completed faster. But we also have to think that we don't have to grind as much either, which saves us time in preparing the joint. But incorrect joint design or a selection of the process that can cause issues with accessibility to weld the joint, meaning if we have something that is too tight in here for the process that I'm using, it might not even be worth the savings that we had.
Thank you for watching. There will be several parts to the lecture. So, weld the world.